We make our next surface, that's the elliptic paraboloid. So this is z square is equal to x square upon b square, y square upon x square upon a square plus y square upon b square. So we can have this equation as also x is equal to y square upon b square plus z square upon c square. Or we can have here y is equal to x square upon a square plus z square upon c square. We can have any one of them. Here is the two are quadratic, one is linear. If, for example, we are having the first four surfaces, x was quadratic, y was quadratic, z was quadratic. There was a difference of minus sign and cone, the right hand side was equal to 0. But here we having the value of one of the coordinate is linear. That's power 1. Here power of z is 1, here power of x is 1, here power of y is 1. If your power of z is 1, then we can have the picture like this one, graph like this one. This is my z-axis, this is my y-axis, and this is my x-axis, and this is my y-axis. This is my y-axis, this is my x-axis, and this is my z-axis. So you can see here our z value must be bigger than or equal to 0. Must be. We can't take negative sign. So we say our graph is only on the positive side of the z-axis. For example, if I put here a value c, and then I have to put the condition on c also. If c is positive, then z is positive. When c is negative, then z is negative. We have to take any real number. But if we take here 1, that means z must be bigger than 0. So if we take here and we will discuss the traces, that for each value of z, we'll get here the ellipse. We're getting here ellipses for each value of z. We can have the set of ellipses. And when we take the value of y equal to 0, and for example, we get here x square is equal to a square z. So it's this one. This is our parabola. So when we take y equal to 0, again we get the parabola. But when we take the value of z only bigger than 0, when z equal to 0, this is a point. As we have mentioned in the last example, that when z equal to 0, then we take also x equal to 0, when x equal to 0, z equal to 0, y is equal to 0, that is a point. And when z value of z is bigger than 0, then we get the ellipses from this equation. So I just described this one with the help of the example. We want to classify and sketch the surface z equal to z minus y square minus 4x square equal to 0. We write in standard form, then z is equal to y square plus 4x square. So z is linear and y and x are quadratic. This surface is elliptical paraboloid. Because here when we take the value of z, this becomes the ellipse. And when we take value of x equal to 0 is parabola, y equal to 0 parabola, that's why say it's paraboloid. When this will be minus, then we say it is hyperbola. And then we say hyperbolic paraboloid. Here we having elliptic paraboloid. Now here what's the axis? Axis because z is linear, y is quadratic, z is quadratic, as I mentioned there, then the axis will be, paraboloid will be z-axis. Here in this case the axis will be x-axis, and here in this case the axis will be y-axis. To sketch the graph, we go for the trace, equation of trace. And name. I give the detail of this one. Here we take the trace x equal to 0. When x equal to 0, what we'll get here? When x equal to 0, z equal to y square. And take here y equal to 0. We take y equal to 0, then we have z equal to 4x square. And we take here z equal to 0, then trace will be, we'll get here y square plus 4x square is equal to 0. And then, as I said, then we can take x equal to 0, and this will be 0, 0, and 0. That's the origin. And here we can see one is quadratic, one is linear. This is a parabola. This is a parabola in yz plane. And here is also z is linear x square. So it's a parabola in yz plane. Now here we take as a note that if we have the value of z bigger than 0, what we'll get here, say z equal to 1, we get here y square plus 4x square is equal to 1, and this is our ellipse. So we say for each value of z, if z is bigger than 1, bigger than 0, this implies the graph will be ellipse. So I just mentioned here now that we are having here z-axis. This is my z-axis. This is my y-axis. And this is my x-axis. Only we take z is bigger than 0. Bigger than equal to 0. When it's equal to 0 is the origin. Now we are having here the parabolas. When we have x equal to y square, z equal to y square, then we are having this parabola in yz plane. This is my yz plane. And this is my parabola in yz plane. Now I have here xz plane. This is my xz plane. This is parallel to x-axis. Now if I take here, I will get a parabola in xz plane, and I just change the color. We are having here in xz plane, when this has the parabola. This parabola in xz plane. Now we are having for each value of z equals 0 is the origin, and then we are having the ellipses. For example, if I take here, this is my x-axis, my y-axis is xy plane, then I have this ellipse. Similar to this one, I have the ellipse here. I have the ellipse here. I have the ellipse here, and so on. These are my ellipses. So this is my, if I take here, and I say this is my elliptic paraboloid, because we have the ellipse, elliptic paraboloid. So I give the example for this one. As the last we're having the example for the cone. I have the surface, and then we have sketched the surface. We have found the traces, equation of the trace, and the name of the trace of the surface, and we have sketched that one. We're going to take the last surface, and that is our hyperbolic paraboloid. And as we've seen here, we're having here minus sign. When this was plus sign, then we're having an elliptic paraboloid. Now if you take the trace, we take here z equal to 0. Sorry, we take x equal to 0 as we are doing. We take x equal to 0. When we take x equal to 0, this is 0. We get here z square is equal to minus y square. Z is equal to minus y square over b square. Then I take here y equal to 0. Y equal to 0 give me z equal to x square upon a square. I take z equal to 0. I get here x square over a square minus y square over b square equal to 0. We can see it here. This is my parabola, because minus sign opening downward. Opening downward. The positive sign, it was opening upward. And here it's positive sign, the parabola opening upward. Then having this equation will be, we can rewrite this one. We can say x is equal to plus minus a over b, y. They're intersecting lines. Line. Then here we can have the value of z. It can be positive, it can be negative. There is no condition on that one. So we can have absolute value of z bigger than 0. Then z equal to, we can rewrite this one. We say x square over a square minus y square over b square equal to z. But this one, this is hyperbola. For each value of z, we have the hyperbola. Now we come to the graph of this one. We're having here, this is yz trace. The series yz trace, and this one is xz trace, and this one is xy trace. So I'm having here the ellipses. For different values of z, where the ellipse opening downward, when y equal to 0 is here is x equal to 0, yz trace, then it's opening downward. Then here we're having the parabola opening upward. This is the parabola opening upward, and y equal to 0. And then we're having this xz, this is xz trace. These are our traces here. This is my This is my hyperbola opening downward for different values of z. These are the values of different value of x and different values of y. We are having this parabola, and we're having this trace, xz trace, xy trace. That's our will be our this is my xz trace, and then I'm having here this is my xy trace. This is like the we say it is on the camel. We put the place to sit that one. That's just like the hyperboloid, elliptic hyperbolic paraboloid. This is like that one. So it's a little complicated because we're having the parabolas opening downward. If we take here x equal to 0 in yz plane, y equal to 0 is simple parabola opening upward. That's what we have seen here. And these are the intersecting lines when in the plane z equal to 0. And when there are different values of z, we are having the ellipse. We are having a different value of z in xy plane. We are having the parabola. This will be, we see here, as I mentioned, we have the, you can go to the book and you can see more information from there, especially for the traces. It's difficult to trace it. I would like to mention it that always I mention this one, that we're having more examples and more problems solved in the notes. And notes I'm putting in the description, the reference for the notes. You can copy notes from there. Then number 1, number 2, you can like it, you can subscribe it, and press the bell icon so that you get the notification. Because we are continuously developing the courses for the mathematics, advanced mathematics, engineering mathematics, students of BSc, FSc, A level. So you can just take it your level, and you can just see the material for that one, that you can read with that, and you can do the practice solving more problems from your books or from your textbooks. Because I mentioned it many times that if you want to learn mathematics, you can't learn mathematics without solving the problems. You have to solve the problems. There are solved examples in the notes. They help you to understand it more. You solve the example from you solve the problem, compare with the solve the example, and compare with the example, solved example given in the notes. So you can identify the weaknesses you are having. Number 1. Number 2, you have the benefit of these video lectures. You can repeat it any number of times you like till you are clear. Then you can skip it. Something you are clear, you can skip that one and go to the point where you want to learn it. So I wish you all the best with this one, inshallah. Next will be our vector value function. That is our next chapter. We're going to start next time.